So your electronics basically has two parts. Okay. That is, one is analog part. Okay. Another is your digital part, digital electronics. Let me tell you what is the sequence I'm going to follow. Okay. So we are starting analog electronics. So first chapter of analog electronics is network analysis. Okay. Second chapter is your semiconductor physics. Or we can call it fundamental of semiconductors. The third topic will be your diode. Okay, diode applications mainly. And the fourth chapter will be your transistor. Basically, we'll do bipolar junction transistor, junction field effect transistor, and we will also discuss MOSFET. Okay. I hope I'm audible to you.
Yes, sir.
Okay. And the last chapter will be your operational amplifiers. So the chapter network analysis is not as such in your syllabus, but this is the basic skill we require. Okay. So because if you see your exam, okay, CSIR, NET, GATE and JAM exam, they are basically asked circuit analysis. All the questions, most of the questions where you will be given a device, and based on and this device based, you will be having circuit. With that circuit, you need to analyze. Okay. So you need the basic skill of network analysis, as well as you should know what is the fundamental of semiconductors. So once you know the fundamental of semiconductor, then only you can understand the operation and performance of these devices like diode, BJT. Okay. And at last we'll consider this your operational amplifier. Okay. So let me begin this network analysis, very important chapter. So before I discuss that what is network analysis, okay, let me discuss first what is network. Okay. So in general, when we see the word network, okay, and circuit, they are interchangeably used, but there is a difference in the definition of a circuit and a network. So let me first draw a network. So what is a network? Okay. So network is basically interconnection of network elements. Okay. Interconnection of network elements. Now what are network elements? Network elements, okay, network elements का मतलब है your resistance, inductor, capacitor, okay, an energy source like voltage source, current source, of course there may be diode, transistor, okay, etc. Okay. So this is a network is a interconnection of network components, network elements. Okay. So let me draw a network now. What is a network? So say this is my, say, a voltage source. Say this is my voltage source. I have a resistance, say R1. Okay. Say I have a another resistance R2. Okay. Say I have one more resistance here, R3, and here I have another resistance, say R4. Okay. So this is the basically a network. Okay, this terminals are open. So this terminal is A, say this is B, say this is C, D, E, F. Okay, so this is example of a network. Now circuit क्या है? What is a circuit? Okay, so circuit is basically a word that is made of circle. Okay, so circle something which is the path which is closed. Okay, so any closed path in the circuit, in the network, okay, which contain a energy source is called circuit. Okay, so now this is a one closed path. Okay, I have two closed paths. This is A, B, E, F, and I have a B, C, D, E. Okay, both are closed path, but this closed path does not contain any energy source. Okay, so I cannot call this closed path as a circuit. This is simple loop. Okay, so there is a difference in the definition of loop, circuit, and a network. Okay, so a closed path. So what is a loop? Okay, what is the definition of loop? So loop is basically a closed path, in circuit or in network is called a loop. Okay, now what is circuit? Okay, what is circuit? Circuit should be closed. Okay,
इसमें एनर्जी सोर्स होना कंपलसरी नहीं है,
सर्किट में कंपलसरी है,
लूप में
होना जरूरी नहीं है. लूप एक क्लोज पाथ है, किसी भी क्लोज पाथ को हम सर्किट में और नेटवर्क में क्लोज पाथ है, उसको हम लूप बोल सकते हैं. ओके, सर्किट इज ओके ए क्लोज पाथ, containing an energy source. एनर्जी सोर्स का मतलब यहाँ पे क्या है? वोल्टेज सोर्स हो गया, करंट सोर्स हो गया. ओके, that will be called your circuit. Okay, now all circuits are network. Okay, all circuits are network, but all networks are not necessarily circuits. For example, now here this is my A, B, E, F circuit. Okay, so if I write A, B, E, F, okay, this is a circuit. Okay, and if I say B, C, D, E, B, C, D, E, this is simply a loop, closed loop. Okay, now if I remove this energy source here, okay, this is still a network. Okay, so because there is no energy source, so we can call it as a passive network, but still it's a network. Network is a basically interconnection of network elements. Okay, so they may have open terminals. Okay, they may not have a energy source. In that case, we will call these kind of network as a passive networks. Okay, so I can write a statement that all circuits are networks. Okay, all circuits are network, but all networks are not necessarily circuits. Okay, is clear?
Sir, passive network वो होगा ना which do not contain energy source.
Yes.
Or which is open-ended. Which one is?
So I told you, if any loop which contain a energy source, that is circuit. Okay.
Yeah.
Any simple interconnection of element, they may have energy source or they may not have energy source. If they are energy source, that is called active network. If they do not contain any energy source, they are called passive networks. Okay. So this is a example of passive network, but we cannot call any part of this network as circuit, or this cannot be called a circuit. Okay. Now if I put a source here, okay, that is a network, active network, but this the part of this one is circuit. Okay. Now if there is a one part only circuit is there, I can call it a network as well as circuit. Okay. So circuit is a big domain, network is the part of this this definition.
तो
Okay.
जैसे मतलब अगर मान लो कि किसी में लूप नहीं है,
हाँ
लूप भी नहीं है
हाँ
और ओपन एंडेड है, तो
हाँ,
दैट विल बी
that
मतलब कंसीडर्ड एज नेटवर्क.
yes, that will be network. So that will be network. Okay. Network is a more general thing. Okay. Circuit is a specialized term. For circuit, there should be energy source. That's it. Okay.
सर सर्किट और लूप में सिर्फ एनर्जी सोर्स का डिफरेंस है ना, जिस
On
जहाँ एनर्जी सोर्स का वो आपका सर्किट का.
yes, yes. Okay.
Thank
Yes. Okay. So now let me discuss something more about your network. Okay. So say if I remove this resistance here, this is my R1. Okay, this is my B. Let me put here a source again, Vs. Okay. So say this is my, I am putting one more source here. Okay, this is my current source. Okay. Now, as I told you, interconnection of a component, network elements or network component is a network. Okay. So network, we can define many terms like node. What is a node? Node in a network. Okay. So a terminal, so these are terminals. Okay. So this is A, B, C, D, C, E. Okay. F, G, H. Okay. These all are terminals. So a terminal, okay, between two components. Okay. A terminal, okay, or you can say a terminal where two or more, a terminal where two or more component means here network elements, component joined together is called a node. Okay. So any terminal where two or more, minimum there should be two or more, okay, network elements component join, they called node. Okay. For example, can you tell me which are the nodes here? How many nodes are there in the circuit?
8.
So 8. So A is a terminal is a node. Okay. B is a node.
Yes, sir.
So can I call C as a node? Okay. I cannot call C as a node because only here one component is coming. And if I see between B and C, there is no resistance. There is no resistance drop. That means this point and this point, okay, they are in same potential. So they are not different node. Similarly, if I say D, okay, if I come from B to C, the potential of B and potential of C will be always same. Because if I say here potential is V, so here also will be potential V because there is no drop here. Okay. Similarly, the potential say BC, okay, that will be equal to VD because there is no potential drop. So these three terminal, okay, they are simply connected by resistance. I can simply pick this one and join here. This is just a representation way circuit. Okay. How to represent, how can I represent this connecting? So this is just a representation. And actually, this B and C and D, they are one point. This is this B, C, D, they are one point. And here they are R1, R4, and this energy source is connected together. So no need to draw this, no needed to draw this line. Just for showing simplicity, a symmetric diagram, I am drawing lines. Okay, if you seek, you can directly connect this resistance. So this, so this point and this point and this point, they are common. Okay, they have same potential. They are connected by just a line, just a simple wire. Okay, so which we assume there is a no. This is the resistance-less wire. Okay, we are assuming. So there is no resistance. Resistance. This is the resistance. This is the resistance. There is zero resistance. It's a zero resistance wire. Okay, just to representation, I am showing this wire. These all terminals, they are common. Okay, and they will make a single node. Okay, so I have a node, one node here. I have a one node here, this second node, and similarly these four terminals. Okay, these four terminals also have a common potential. Okay, they are just connected by zero resistance wires. Okay, so these common, all common also form a single node. Okay, so in this circuit we have node. Okay, number of node is only 3. Are you getting the definition of node?
मतलब नोड के लिए पोटेंशियल डिफरेंस 0 होना चाहिए।
पोटेंशियल होना चाहिए, साथ में ये एक ही नोड है ना, इनमें तो सेम पोटेंशियल है। ये तो जीरो रेजिस्टेंस वायर है, इसका कोई मतलब थोड़ी है। जस्ट दे आर फॉर रिप्रेजेंटेशन of symmetric circuit as a nice way to draw. I can directly put in, and actually when you make circuit on whiteboard, how do you make? You take resistance and you connect. Na? You don't put connected and you put a wire. Just you put the wire just to make a short. Are you getting my point? So this is just a zero resistance wire. Okay. So I hope the definition is clear. Now the second definition is what is branch. Okay. So
B to G.
Yes.
Sir, B to G. It varies.
B to G. There is resistance, na? So the potential will not be same here.
So that is node, no, sir.
G. G is a node. G is a node. This H, G, F, E. They are common node, na?
C and F. That one varies, no, sir.
This A, B, C, D. They all are connected by simple wires. They are all shorted. They are all shorted. Shorted means what? Same 2 points are shorted means what? They are 1 point, na? These 2 points are shorted by a zero resistance wire. So these are all shorted points. So they are not a different node. Similarly, if you see this one, okay, because the definition of node is what? A terminal which join 2 or more components. So here one component is there. Where is other component? Here is only one component, and one component is coming from here. Are you getting?
Yes, sir.
So this is not a component. This zero resistance wire. Okay. So this point and this point. Okay. This their common point. So this is also a node. I hope the definition is clear.
Yes, sir.
Okay.
Yes.
Now the second thing is branch. Okay. So in this circuit we have N equals to 3. Okay. Now second thing is what is a branch? Okay. So branch is simple. Branch we call it a component. Okay. So a component. Okay, between two nodes. Okay, is called branch. Okay, so can you count how many branches are in the circuit? How many components are there in the circuit? So any path or any component between two nodes. So this node, one component, 1, 2, 3, 4, 5. Okay. So the number of branches, how many? 5 in the circuit. So I can write B is equal to 5. Branch means any path, okay, between two nodes, different nodes, okay, or any component between two nodes is called a branch. This is your one branch, second branch, third branch, fourth branch, fifth branch. So I have a total number of 5 branches. Okay. And the next definition is loop. Okay. Loop I have already discussed. Okay. A closed path. Okay. Now similarly a circuit is also a loop. Okay. Loop is a definition, a closed path. Okay, a closed path is a loop. Now, can you tell me how many loops are there in the network? Anyone? How many loops are in this network?
5.
5.
6.
6.
5.
5, 6. Okay. So 4. Okay. So this so this is a loop. Okay. So ABGH is a closed loop. Okay. Similarly, BCFG is a loop. CDEF is a loop. Okay. Then ACFH, that also loop. ACFH is a loop.
6 loops only.
6 loop. BD. Okay. So I'm completing this. BDEG is also a loop. And the bigger loop, final, which contain these 2 loops, A, D, okay, E and H is also a loop. Okay. So if I ask you how many loops are in the network, we can simply call there are 6 loops in the network. Okay. Now these quantities, okay, can be connected, whatever written, nodes, branch and L loop. Okay, this can be connected. So before I finish, there's one more definition called mesh. Okay, what is mesh? Okay, so loop is not important for us. Okay, for important terminology here is mesh. Okay, because you may have heard when we will solve a circuit, we do mesh analysis. Okay, so what is a mesh? So what mesh is a closed loop, an independent loop, an independent closed loop. Okay. Now what is the meaning of independent? Independent का मतलब है a loop which does not contain, okay, does not contain any other loop inside, it is called your mesh. Okay, so any independent loop, okay, which does not contain any loop inside it is called your mesh. So can you tell me how many meshes are there?
3.
3.
Meshes are 3. Okay, so these are 1, 2, 3. They are independent loop. Okay, if I consider A, C, F, G, this cannot be called a mesh because it has a one loop inside. So independent loops, okay, which does not contain any other loop is called mesh. So here we have 3 number of meshes. Okay, so once we have defined these terms, okay, now let me give a important theorem, okay, which is called circuit topography. And from circuit topography, okay, this relations comes the number of branch of any network. Okay, it's the general equation. So this is a number of branch is equal to number of meshes, number of node minus 1. Okay, if you have any network, so if you can calculate the number of meshes and number of nodes, you can find out what is the number of branches. Similarly, out of these 3, any 2 quantities you can find out how many what is the third quantity. For example, here meshes are 3, okay, nodes are 3, so 3 6 minus 1 5, so branches are 5. Okay, so for any network we can apply this relation. So I hope the terminology is clear to you. So I have given the definition of network. Okay. Now I want what is the network analysis. So
Sir,
shall I proceed? Yes.
so this the equation you have given, the B equals to M
Huh.
N plus what you said this.
This is for circuit topography. You don't need to worry
Okay.
about this one. This just comes from this. This is it's a completely engineering subject. Okay, circuit topography. Now let me define what is the network analysis. So network analysis. Okay. Network analysis means, okay, finding the currents and voltage. Okay. Finding the currents and voltages, okay, across every component okay. Current, if you know the current, you know the voltage, you can of course calculate the power also. So finding the current and voltages across every component of network is called network analysis. Okay. So if I have a 5 component the previous network, if I can find the current across each component, okay, or voltage across each component, so that means I know I have the knowledge of full network. Okay, I have analyzed the full network. I know the each branch what is the current, I know each node what is the voltage. Okay, so that means I have complete information of this network. That is called network analysis. Now network analysis, we have to find current and voltages, okay, and of course power. So these are basic circuit quantities or basic network quantities. Okay, so the what is the basic circuit quantities? Basic quantities in network. Okay, which we are interested, basic quantities in network. Okay, so number one is your current, of course charge is the fundamental. Okay, so the flow of charge gives you current, and you know what is current? Current is simply dq upon dt. Okay, and dq upon dt means this rate of flow of charge, rate of flow of charge, okay, is called your current. Okay, similarly if I want to define voltage difference, okay, or voltage, what is the definition of voltage? Okay, anyone? What is the voltage?
Speed work done to move a unit positive charge
Hmm.
is known as the voltage applied.
Exactly. Okay.
Potential.
So if I want to bring a unit charge from infinite to some point, okay, the work done to move this charge from infinite to some point is called your voltage. Okay, so basically what is d omega by dq, okay, is called your voltage. Okay, the work done, okay, bringing a unit charge d by dq from infinite to some point a is called your voltage of that point. Okay, similarly in circuit I am interested in mainly in voltage difference. So what is voltage difference, say ab? So bringing a charge, okay, from a to b, okay, how much, bringing a bringing a unit charge from a to b, how much work has to be done? That will be equal to your voltage difference vab. And we should remember that in a circuit always my vab is equals to minus vba. In a circuit vab equals to minus vba. For example, if I have say a terminal called a and I have terminal called b, if I say the terminal a has a 9 volts compared to b, okay, so this is equivalent of saying that b has a minus 9 volt compared with respect to a. Okay, if terminal a is 9 volt with respect to b, so b has a minus 9 volt with respect to a. Okay, this point is clear, very important point because we will use in circuit. So if point has a voltage v with the reference point, the reference point has a voltage minus v which is point a. Okay, and the next thing is power. So once we are done this one, we can start our network analysis. Now the next thing is power. Okay, so power is, all of you know, okay, power is the rate of work done. Power is symbol P. Power is dB of dW. Okay, where the W is showing here by work done. So rate of work done. Okay, rate of work done. So energy is what? Energy is the ability to do work. Okay, and power is what? How fast that work can be done, how fast energy can be delivered in a system. A system has the ability to do work, that is called energy density. Okay, and that, like a battery, like capacitor. Okay, they are storage devices, they have energy. Okay, energy density per unit volume, per unit weight. Okay, how much energy they contain, that is the energy density. And how fast they are able to deliver that energy which they contain, that is called power. Okay, so some device has a more energy, that doesn't mean that has a more power. Okay, like your capacitor is a power device. Even though energy and your battery has a high energy, but like capacitor, or nowadays people are working on super capacitors. Okay, super capacitors, they have high power. They can deliver that, they energy in burst, in a few seconds. Okay, they can give burst. Okay, they can give acceleration, fast acceleration. So power is the rate of work done or, okay, rate of energy delivering. Okay, or how fast, okay, rate of work done or rate of delivery of energy, okay. Now if I want to write power, okay, I want to measure power in a circuit. So how can I measure power in circuit? So I have d omega, I can write dq, I can dq upon dt. Okay, d omega dq is your voltage. Okay, and dq by dt is your current. So if I can measure any branch, any resistor, what is the current and what is the voltage difference, so I can know how much power it is consuming. I can know that power. Okay, so power also can be right from this equation. Okay, if I want to derive how much work has to be done, if I know the power, I can calculate, okay, p dt, how much work has to be done, okay, delivering this power from time t1 to t2. Okay, so these are the simple definitions, equations, okay, which you people are already familiar. So that a circuit analysis means simply I need to calculate currents and voltage across every component and every branch. Okay, now let me start network analysis. Okay, so how network analysis is done when you have a circuit given. Okay, so these techniques we will learn, okay, one by one. So let me give a outline how we are approaching this network analysis. Okay, so network analysis, means you want to solve a network. So the first approach is you use basic laws. Okay, if any simple circuit is given, you can simply apply basic laws and you can find out, okay, the current and voltage in the circuit. Okay, and what are the basic law? Number one law is your Ohm's law. Okay, so if you know a resistance, okay, you know current I is flowing, resistances are, so you can use this law and you can say maybe equals to IR. Okay, isn't it? That's a simple thing. So any simple circuit, in principle you can solve any circuit using this basic law, but once circuit complexity increases, once your circuit become larger or complicated, then only just this basis law will not be sufficient. Okay, they will not be efficient techniques. We cannot quickly solve. Okay, so this, what is the basics law? So this is the Ohm's law. Number 2 is your Kirchhoff's current law. This is called KCL. Okay, and the number 3 is Kirchhoff's 3 कौन सा है?
Voltage law.
Voltage law.
voltage law.
That is called KVL. These are the basics laws. Okay, by using this basics law, we can try to solve a circuit if it is possible quickly. Okay, and so if if the circuit is complicated, then I will use this laws, okay, as a technique. Okay, so we learn some techniques which help us to solve quickly a circuit. Okay, that is circuit analysis techniques. Okay, so there are 2 important techniques. Okay, the number 1 is your nodal analysis. Node analysis means you know already what is node. So if I'm able to find the voltage of each node in the network, okay, हर terminal पे, if every node terminal, I know the voltage. Of course, I know the current in the circuit. I know the voltage difference. If I know the resistance, I know the current. Okay, so in this technique, we focus on calculating voltages of node. Okay, and the second technique, which you people are all familiar, you are doing from your 12th class. Okay, that is your mesh analysis. Okay, so what you do, you calculate currents in the meshes. Okay, that is called your mesh analysis. Okay, very important technique which helps us to solve any network. Okay, now once these techniques, we have laws, still based on these techniques and these laws, there are some theorems were derived. Okay, those theorems are, I can call them very quick techniques. Okay, very efficient technique. If you know certain theorems, okay, immediately you may have a very complicated circuit, but within a few minutes or within a few seconds you can solve the circuit. Okay, and those are called your network theorems. So if you have a mastery, you can solve very quickly any circuit. Okay, so these are network theorems. So we will not go all the network theorems. So we will only consider the theorems which are very frequently used and useful in our syllabus. Okay, which will help us to solve the circuits of transistor and circuit of operational amplifier. So the most important I call, okay, these are superposition theorem. Very simple technique. Okay, number 2 is I'll be using what, which is the next technique, Thevenin's theorem. Okay, Thevenin's theorem. Okay, and the third one is your just a modification of this Thevenin theorem called Norton's theorem. Norton's theorem. And the last is, okay, called maximum power transfer theorem. Maximum power transfer theorem. Now we'll take each thing by one, and we learn network analysis. Okay.
Yes, sir.
Okay, sir.
So I can erase this one, na?
Yes, sir.
Yes, sir.
Okay. So first thing is your Ohm's law. Okay. Ohm's law everyone knows. Okay, but let me just discuss so that you can have a little bit doubt, which is you can clear. So Ohm's law says that V equals to IR. Okay, V equals to IR means that when a resistance R, okay, if current I is flowing across the resistance R, okay, the voltage difference, suppose I am applying a battery here, okay, say V. So this the voltage drop will be here, V of course, okay. If you say here there's a one resistance only, so whatever we apply, that will be V will drop here. So say this is a resistance, okay. So voltage drop is VR, V equal to IR, okay. So but you have to keep, you have to one thing you have to keep in mind, there is some sign convention. Here I am measuring, this is B plus, this minus, okay. That means when I am measuring the voltage with voltmeter, okay, I am measuring like this. This is my voltmeter plus, this is my voltmeter minus. So this polarity is important. How do you are measuring a voltage? So if you are measuring like this, because whenever current always flow from higher potential to lower potential, okay. So you can note this down. Current flows from higher potential to lower potential. So when current is going from here to here, this is higher potential, this is a lower potential. But suppose if you are measuring your resistance somehow like this, current is moving like this and you are measuring like this, you are measuring opposite. So of course this is higher potential and this is lower potential, but you are measuring oppositely, you are measuring the potential of this point with respect to this one. Okay, here you are measuring the potential of higher point with respect to lower, that is V equal to IR. But you are, if you are measuring oppositely, okay, actually here's this higher potential, this lower potential, but you are measuring the potential of this point with respect to this. You are changing the voltmeter polarities. Suppose you have a digital voltmeter, so if you are measuring like this, you'll get 5 volts, for example. And if you same resistance and same current, you measure, you put digital meter opposite, then what will you get? You get 5 minus 5 volt, isn't it? Are you getting my point?
Yes, sir.
If you have voltmeter, if you're measuring like this, you get 5 volts for given I and R. Okay, if this is 5 volts, and if you same voltmeter you take oppositely, you measure the voltage of this point with respect to this, you'll get minus 5 volt. So whenever like this things happen, current is moving, and your polarity of voltmeter, what you're measuring, how you're measuring, okay, that will be given by V equals to minus IR, because you are oppositely measuring. Here you are measuring this point with respect to this, and in this case you are measuring this point with respect to this point. Okay, this is higher potential actually. Okay, so you will opposite. So this is called sign convention. Okay, so this sign convention you should be clear. Okay, so are you any doubt in this thing? Okay, so just if current is moving and voltage drop is like this, okay, but you say no, I want to measure like this, so measuring this one is different like measuring this one with voltmeter. Okay, this is only polarity. So they may give this one, and you say that, and they're asking what is this voltage, so you will say 5 volts. This is not 5 volts, so minus 5 volts. Okay, this is a 5 volts. If there's a, this is a, say this is a 1 ampere current, 1 ampere current, and say this is a 5 ohm resistance. So voltage drop, what is voltage drop is 5 volt in this case, but if you're measuring oppositely, that is minus 5 volt. Okay, you should keep this in mind. So this is your Ohm's law. Okay, now we are moving the next important law, Kirchhoff's current law. Okay, so what is Kirchhoff's current law? Okay, so Kirchhoff's current law says algebraic sum of currents at any node any node is 0. Okay. So suppose a node is circuit P and there are many currents are coming. Okay, say this is I1, say this is say I2, say this is I3, say this is I4. Then sum of the currents at any node should be 0, because this point does not contain any charge in circuit. In circuit, charge is always flowing. Okay, there is no accumulation. Even though currents in circuit, currents are moving. For any point, there is no charge accumulation. Okay, that means the current entering to a point and current leaving that point should be same. That means the algebraic sum of current should be some 0. For example, here if I say I1, okay, I2. So always just there is sign convention. Okay, you can take incoming current as a positive or outgoing current as a negative. Okay, it is a choice. You can also take incoming current as a negative and outgoing current as a positive. There's no difference. That is only sign. Okay, they both will give you same result in circuit analysis. Thus you have to keep one choice and you have to remember what you are assuming one at a time. You cannot confuse. Okay, so if you can take incoming currents as a positive or incoming current as a negative. Okay, so I generally take outgoing current as a positive. Okay, that helps me to solve understand the circuit quickly. You can do opposite whatever your habit. Okay, so for example, if I take I1 I2 positive, okay, assuming incoming currents are positive, then outgoing current will be negative. So these are outgoing currents I3 I4. Okay, and this algebraic sum of this one. Okay, so algebraic sum means you should have any current, any circuit. Okay, if there are k currents are coming, the sum of algebraic should be 0. That means if I write it this way in another way, I1 plus I2 equals to I3 plus I4. Okay, so this means current entering to a node, currents entering, okay, towards node is equal current leaving the nodes, currents going away or currents leaving the node. Okay, both are equal. Now if you take outgoing incoming current negative, then minus I1 minus I2, this is, you simply can take minus common, 0, but the result will be same. Incoming current is equal to outgoing currents. Okay, this is called your Kirchhoff current law, and this is based on what? किस पे बेस है ये? This is based on
Charge conservation.
charge conservation, because charge cannot accumulate at any point in the circuit. This is called charge conservation. Okay, this is another form of charge conservation. Okay, so let us solve some problem based on this law. Okay, so in a circuit you should able to find out, okay, what is a node, what is a branch. Shall I erase this one?
Yes, sir.
Yes, sir.
So I'm giving you a simple circuit. Okay, you have to first, before solving this one, you need to tell me, okay, this is a current source, इसमें कितनी ब्रांचें हैं, कितने नोड हैं. Okay, so this resistance is say RC, this resistance is RB, this resistance RA. Okay, and this is the 18 volt here. Okay, so can you tell me how many branches are in the circuit and how many nodes are there in the circuit? Okay, so let it say this is a current source. Okay, so this is a represent, this is a voltage source. Okay, so this is your voltage source. Okay, so you represent voltage, this is a voltage independent source, voltage like this, or you can represent like this, is a voltage. Okay, and current source you represent by this symbol. This is a current source. So you can call it RA, R1, or you can say R1, R2, whatever your choice is, R2. Okay, R2. Okay, and so
5 branches.
yeah, yes. Branch kitni? I'm changing the circuit. 1 minute. Okay, so R1, R2. Okay, one put more resistance here. R1, R2, sorry, R3. Okay, and this is your a current source. Okay, now please count how many. Okay, so this is my say A,
अभी
B,
भी 5 branches.
T, E, F, G, H. Okay, so this is a node 1,
3 node है.
this is a common node 2, and this is your, this is the same circuit now what we use. Okay, so that is a three nodes. Okay, 3 nodes and 1, 2, 3, 4, 5 branches. Okay, so nodes are 3 and branches are 5. Okay, now what I'm doing, I'm saying that this source is giving me 3 ampere current. This source is giving me 3 ampere current, and this source is giving me 5 ampere current. Okay, and I know the current in going in R2 is 2 ampere. Okay, so I need to find the current going in this R3 resistance. So what is the current going in R3 resistance? I. So please find out I. I means IR3. This is a simple question. Okay, 3 ampere current is coming here and 5 ampere current is coming. These currents are coming towards what? किसकी तरफ आ रही है करंट? एक नोड की तरफ आ रही है.
B की तरफ.
Yes, sir.
So these all currents are coming towards a node. This is a single node. Okay, so I can just apply what? I can apply KCL.
KCL.
So apply KCL at node. Okay, so incoming currents are 3 ampere plus 5 ampere, and outgoing currents are how many? 2 ampere plus I. So what is the value of I? 6 ampere.
Yes, sir.
Are you getting my point? How to calculate, how to apply this KCL? Okay, you have to see how much currents are coming and how much currents are going at a node. Okay, so this B, C, D is a node. So in this nodes, 3 ampere current is coming. Okay, and 5 ampere current coming towards node, and this current 2 ampere is leaving. The I also leaving. So incoming current 3 plus 5, leaving current 2 plus I. So from here I can calculate what is the value of I. Okay. Any doubt in this question? Yes.
5 means it is incoming current, no, sir?
5 ampere is incoming current. Na? The current which is coming towards this node, this single node, na? You can say this is I, single node, or you can say some F, N. This is single node. So this 5 ampere current coming towards the node. Okay, 2, 3 also coming towards the node. This is leaving the node, going away. This is also leaving, going away. So incoming current equal to outgoing current. So you can calculate the current. Okay. So let me solve one more problem. This point is clear.
Yes, sir.
Yes, sir.
Now you have say +1 18-volt battery. I am just solving in the circuit by KCL. Okay, no other thing. I'm just giving you a practice of KCL. Okay. So this is my current is going say IA. Okay, this is my RA. Okay, say current going in this circuit is IX, and the resistance is 6 ohm. Okay, this source is giving 13 ampere current. Okay, and this source is giving 8 ampere current. Okay, so can you find what are the unknown things? IX Okay, and RA, IEX and RA, can you find out? So first you need to find out node. Okay, so this is a common node. Okay, so how much currents are coming towards the node? Is 8 ampere coming, is a node. Okay, so 8 ampere current is coming, 30 is also coming, isn't it?
But sir, 1 ampere is going towards RE, na?
This is not 1 ampere, this is IA.
Oh, okay, sir.
You need to find out. Okay, 1 ampere, just give me 1 minute. This is
So two should be there, no?
okay, yes. Okay, so now you have to tell me how will you solve this circuit. Okay, so what is the voltage drop across this circuit? Can you tell me?
IARA.
18 volt
18 volt, very good, because they are parallel circuit.
parallel circuit.
Yes, sir.
Okay, there is no resistance here, they are parallel. Parallel का मतलब end to end connection है. What will be the voltage drop across this circuit?
18 volts.
18 volt, very good, because these circuits are parallel, na? There is no resistance here, these are parallel end to end connection, so the voltage drop is here 18. So what is the value of IX now?
3 ampere.
Ohms law.
Okay, 18 upon volts, voltage upon resistance 6 ohm, so 3 ampere. Now you know 3 ampere current. Can you calculate now what is IA? Now you know this current coming, this current coming, this current going, this current going. So 4 out of 4 current, 3 currents you know. Remaining 4th you can calculate using KCL. Okay, so you know 8 is coming, 13 is coming, IA is leaving, and IX also leaving. IX is equal to 3 ampere. Okay, so what this will give me? IA will become what?
18 amp.
18 amp. Very good. Okay, so now you can tell me what is RA.
1
1
ohm.
No, very good. Now you know this voltage 18 volt. Now you know the current also 18 ampere. So 18 divided by 18, you have a 1 ohm resistance. Okay, so this is that's it. I asked just these things. Okay, so this was your KCL. Now I'm stopping here. Okay, and tomorrow we'll continue with KVL and other techniques one by one. Okay, so this KCL, this network analysis will take at least 6 to 7 classes. 6 to 7 classes. Why? Because now what we are dealing, that is simply a resistive circuits. Okay, but when you go for op-amp or some circuit, there will be a capacitor also in the circuit, there will be an inductor also in the circuit. So we need to add those element also. So what we are here doing here, that is basically linear network analysis. Okay, linear network analysis means our component are linear. Our components are linear means they do not, their value do not vary with the voltage and currents in the circuit. For example, resistance, the value is fixed. Okay, regardless how much current is flowing, how much voltage across the resistance, this value is fixed. It will not change. This is not variable resistance. Okay, so that is resistor is a linear component. Similarly, if inductor, if it is not a variable inductor, or if its value inductance is constant, okay, then that is a linear component. Similarly, capacitor, okay, if it is a capacitor's value is constant, then that is also called linear component. So we'll consider only those capacitors and all inductors which value do not vary. So first we learn how to solve linear network analysis. Okay, so first I started with resistive network analysis, the network which contain only resistance. Okay, how to solve. Then we will see if there is an inductor, how can we approach the problem, and when there is a capacitor, how can we approach the problem. Okay, and once this part is covered, okay, and then we will go to first we will do DC analysis also, and we will see at the late whenever we require, I will show you some how to do AC analysis also of the circuits. Okay, so thank you very much. I'm stopping here now today.
Thank you, sir.
User.
Thank you, sir.
Good night, sir.